Welcome, this is Mr. TG. This is lesson 2-3 for Algebra 2. Today's lesson is on linear functions and slope-intercept form. Hopefully this lesson will be a review for you from Algebra 1. I think what we'll do first is start by talking about what slope is. Um, when we deal with linear functions, we need to know basically how to measure the steepness of a line. As you can see from your guided notes there, I've got several examples listed. First, I think I want to show you just actual lines and show you characteristics of slopes and how to measure that slope. If you look at these lines that are pictured, they all have a certain steepness, and that's what slope measures. It's a ratio. We like having our slope as a fraction. Most of you like to work with decimals instead of fractions, but with slope, it's better that we work with fractions so we know what we call the rise of a run. Now the definition of slope of a line is right here. Basically is the vertical change over the horizontal change, or as you probably were taught, rise over run. Another way we can measure slope is using this formula right here. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Universally, the slope symbol is small m. So when you see that small m, you will always know that you're dealing with slope. Though x sub 2, one other note here, when x sub 2 minus x sub 1 is 0, we say our slope is undefined. So if our run is 0 at any given time, our slope becomes undefined. So let's go down to these lines and let's see if we can calculate slope. The first thing you have to do is identify two integer order pairs on the lines. And what I mean by that is find 2 points that work out without decimals, such as this point right here, 2, 0, and this point right here, 4, 1. So that's your first objective, is to find 2 points. It doesn't matter which 2 points you select. Just make sure that they are in the integer order of pairs. Again, that means they don't have decimals or fractions. Now, since this line right here slants to your right, I call this going uphill. It's slanting to your right. This one's going to have a positive slope. So right away, as soon as we see a line that's slanted to your right, you know automatically it's going to have a positive slope. Just like number 4 here, I know when we do that problem or that slope, we're going to have a negative slope. Now to actually calculate the slope, you make a step out of the 2 points. And this is what I mean by that. You can just draw a vertical line up to the same level the next point is at, and then a horizontal line across. Then measure or count, this goes up 1 and goes over 2. Now here's the common mistake that kids make. They want to put the change in x on top because that's how you graph. Slope is just the opposite. It is the change in y, which in this case would be 1, over the change in x, which of course is 2. And that there becomes your slope of that line. Again, it doesn't matter which 2 points you select. If I select this point, looks like that's an integer order pair, and I calculate the rise over run. As you can see here, the rise is 2 and the run is 4, and 2 over 4 is still 1/2. So we're dealing with the slope of line 5 to be a positive. It's positive again because it slants to your right. It's going uphill is what I like to say. And the rise is 1 and the run is 2. Now for the negative slope line, the one that slants to your, I call this going downhill. This one actually goes downhill at quite a rapid climb. Let's find 2 points that are on my line. The first thing we've identified, it is negative because it's going downhill. And then again, you can make a step out of it. You can just go over 1 and down, goes over 1 and down, 1, 2, 3, 4, 5. So again, we're measuring. Now, the one thing about negative slopes, just assign the fraction as a negative. You don't have to apply it to any specific number in the slope. You would end up taking the rise, 1, 2, 3, 4, 5, and put that on top, and the run, which is a negative 1, and put that on the bottom. So our slope becomes a negative 5 over 1, which we can call negative 5. So that's the slope of that line. Again, it's negative because it's going downhill. There's a lot of ways you can go through this. If you like the concept of you're going up 5 and then left 1 is negative, so it becomes 5 over a negative 1, so it's negative, that's fine. Whatever works for you. But what I do is I look at the slant, which way the line is slanting. If it's positive, I call the slope positive. If it's negative, I call it negative, like this one is negative. Negative is going downhill, positive is going uphill. Now what happens if there isn't a slant to our line? For example, let's say we've got these 2 points down here on this horizontal line. Now this is going to be a problem. Some of you will memorize which one has a negative, which one has a no slope and which one has an undefined slope, because that's what's going to happen here. But mathematically, here's what we have to make sure we understand. In this setting, from this point to this point, the rise is 0 and the run is 1. So the rise is 0 because we're not actually going up at all, but we are going over. We have a run but no rise. In math, we're okay with that. That's 0. So we basically have a slope of 0. With vertical lines, however, we have a little bit of an issue. Let's identify 2 integer order pairs, and let's take a look at what our rise is. Well, our rise is 3, and our run is 0. Vertical lines, as you can see, forces us to divide by 0. We cannot do that. So this slope is undefined. Yep, undefined slope, or you can just say no slope, whatever is easier for you. It doesn't have a slope. So no slope, or you can just say undefined. It's undefined because of the fact that the run is 0. And we can't have at 0 on the bottom. An analogy you could use to help you remember this is think of how fast, if you're on a ski slope, you're going. If you're on a horizontal surface, if you're on a horizontal surface, you're going 0 speed. And then if you're going on the vertical surface, you die. And so that you don't exist. So if that helps you remember, that's great too. But we want you to understand the concepts of why one is no slope and the other one is 0 slope. It will help you remember. Now the next step is to figure out slopes of lines without graphing. So what we're going to primarily do is use this formula, which I'm sure you're familiar with. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What this allows you to do is find that rise over run without graphing. If we do that here in problem number 1, we'll end up with the following. We assign the first coordinates as x sub 1, y sub 1. The second order pair is x sub 2, y sub 2. It does not matter which one you call x sub 1, y sub 1, or and which one you call x sub 2, y sub 2. We just go in order if you like. In this setting, what would happen here if we substituted these values in problem number 1, you would take negative 1 minus 1. And where did I get that from? Those are your y's right here. Negative 1 minus 1. And that would be over 5 minus a negative 3. Now be careful with your negatives. As you can see here, there's a minus that comes to us with the formula. Also, make sure you put your y's on top. So we got a negative 1 minus 1 on top, and 5 minus a negative 3. If we simplify this, that turns into negative 2 over 8, which can be simplified down even further to a negative 1/4. So our slope in number 1 is a negative 1/4. That would be the slope of our line. Okay. Now take a moment and you try number 3 and number 2, and go ahead and see if you can find the slopes of those 2 sets of points. I'll put it on pause and give this a try and see how it goes. Okay, welcome back. Let's see how you did for problems 2 and 3. Notice I've cleaned off the old work, so hopefully you took good notes. If we look at number 2, again, we're going to call this x sub 1 and y sub 1. By the way, these are subscripts. There's numbers that indicate that we have 2 x's. Here's it's called x subscript 1, x subscript 2. And then we got y subscript 1 and y subscript 2. It just identifies the two different y's and two different x's that we have. If you do that, we end up with negative 5 minus 2 as my numerator. Again, I need to overstress this because it's a common mistake. Make sure you subtract your y's and put that on top. And then 4 minus a negative 10 is on the bottom. Simplify, you end up with a negative 7 over 14, which is a negative 1/2. There's your slope for number 2. Hopefully that went well. For number 3, if we do the same thing, let's erase that previous problem, and let's take again, and let's identify x sub 1, y sub 1, x sub 2, y sub 2 as your two sets of points. We would end up with 8 minus 8 over 2 minus a negative 3. Now you'll notice in this one we end up with 0 on top and 5 on the bottom. And if you see that anytime 0 pops up on top, that means our rise is 0, but our run is 5. We're okay with that. So we have a 0 slope existing here. That's very similar to the graphing problem down here where we had a 0 on top and 1 on the bottom. The run is some number. The rise is always 0. That equals 0. Now if you were going to do this with a set of points and 0 popped up on the bottom, then you write undefined. Don't put 0 because it doesn't have a 0 slope. Write undefined for your slope. So this is something that you've had in geometry, algebra 1. It's something that shows up all the time, and kids have a hard time with this because it's involving fractions. So please let me know if you have any questions. This will complete our first video on slope. Hopefully that went well, and continue on to the second video.